I've had a couple of these power supply kits laying around for a number of years, 5 or 6 years. At that time they were sold on eBay as a LM317. Well, they do have an LM317. More recently I've seen them sold as IRF 3205. Same preceding words. Now the YouTube channel Voltlog did, I think, one video, maybe two, where he assembled the power supply and then tested it. And he sort of panned it and said it wasn't good enough to enclose in a case. He just did the board and tested it. Now he's very qualified to talk about this. The only reason I'm building it is I've already got the kit. Other than Voltlog, I don't know of much information about this kit on the internet. This first sentence is almost gibberish, down to this period. This should say IRF 3205, can be with a 75 NF75. Okay. I copied this from the years ago eBay seller's site. And it's not much better. Now this is advertised as a 15 volt power supply, and the intention is to use a 15 volt transformer. The supply output is 5 amps, so it makes sense that this transformer would be rated 5 amps. I intend to use this 24 volt AC 5 amp transformer. Initially, I think I'll reduce the input voltage to create 15 volts. If the power supply looks like it's worth pursuing, I'll disassemble this winding and remove enough turns to bring the output down to 15 or 16 volts. As is the case with most of these Chinese kits, you get a rather well done silkscreen, silver plated, nicely done circuit board. Voltlog does caution that these LED pictures are backwards perhaps. As you see, there's no room on the board for a heatsink. And like all the Chinese kits I've built, I'm not going to dump them all out. It's just a bag full of components. Whoops, there we go. Just a bag full of components. And I'm going to stuff them back in the bag before I lose any more. Now, I'm not sure how this rail is developed. It appears to be fed through D1. And D2 for that matter. But I think you could replace, I'll have to find this out. We'll find out when we build it. If we can replace this 15 volt AC supply with a 15 volt 5 amp wall transformer, a DC supply. So I'll get started. Normally when I assemble a Chinese kit, I don't inventory the parts like this. I usually just go by what's written on the silk screening, and I put the parts in by value. I sorted them out for the power supply to make a bill of materials with part number assignments. I also took the time to redo the schematic. A couple of things are changed from the Chinese schematic. For example, C10 is called out on the Chinese schematic and the circuit board as being 100. The kit included a 220 microfarad capacitor. R4 is shown on the Chinese schematic as being a 120 ohm resistor, but the silk screening and the components supplied with the kit did not include a 120 ohm resistor, they included 150. This was described as a bridge. I described it as 4 individual resistors. Now, once you install the parts, the value of the part disappears. See, when I put a resistor in here, I know it should be a 20K resistor. Once the part's inserted, I lose all this data. So I prepared a drawing of the circuit board. This is not quite to scale. And I included all the part designations referenced on here. And to fill in the space at the bottom, I put all the component, well, not resistors and diodes, but all of the active components and their pinout. I think I'll get started. When I'm building something like this, I prefer to use these brass blocks. They're sold by QRP-Me. They're installed on the 4 corners of the circuit board with this screw on the lead side, the component lead side. Now, when they're installed, I might have obscured, I'll say, a hole. You can see it down there. There may even be one underneath it. When I get to that, I'll just take the block off or move it to a more convenient location. What this does is it provides a level space. The blocks are somewhat heavy. That allow me to form the component leads, stick them through the hole, turn it over. Now the leads are all sticking up. If I did it the other way, if I had installed it with the screws sticking up, the board would be lower to the table. But when I turned it over, there'd be no room for the leads. You'll see what I mean in a minute. I'm going to start with the carbon film resistors first. I'm going to install the component that adds the least amount of height or thickness to the board. I have a set of leads to the bench meter, and it's set on ohms. I'm going to randomly pick up a resistor. The resistor measures 1.005 megohms. This resistor has little pieces of paper. I will cut them off. So I'll look for a 1 meg resistor. There's the 1 meg. So I've bent the leads, push it down. And the leads sort of spread themselves automatically, and I'm good to go. And so forth. I'll pluck another resistor out. I don't like to use flush cut nippers. I don't want to cut into the soldered ball. So I'm going to proceed to do this until all the resistors are in place. Here's the board with all the resistors installed, 19. There are 20 resistors, but one of them's a big fellow. It sits here. It's pretty high. The next 5 components I'm going to install are the glass diodes. They're all 1N4148. Now, there's something in the kit that looks very similar to them. It's a glass bead. There are no markings on it and no polarity line. There are no markings at all. This is a 10,000 ohm thermistor. It needs to be set aside. The diodes, one end has a black band on it, and that will correspond. This line is the black end of the diode. There are 6 more diodes. These little fellows are 1N4004, and these big fellows are 6A10s. Now they have black bodies, so the identifier is the white line. Some of them are pretty faded, but the white line matches up with this white line right here. And see, these diodes are facing in opposite directions. The 6A10s, being much bigger, have nice prominent white lines. I'm going here and here. And I have to move this block, but they go here and here. When installing these 6A10 diodes, they have really massive leads on them. There's no sense leaving this long lead on and trying to solder it, because this lead acts as a heat sink. It's bad enough the diodes are over here. Now the rest of these components, I don't cut the leads until I've soldered it. You may want to cut the lead before you solder it, and to keep from cutting too close to the board, invert your pliers. That automatically will leave enough lead. So here's the board with all the resistors, glass diodes, and epoxy diodes installed.